Good afternoon. Thank you for joining us today for this exciting webinar on innovative testing techniques in the white goods industry. I'm Isabella Bondani from IRS, and I'm pleased to be here as your host and to introduce a panel of experts who will share their insights and experiences in bringing innovation to the forefront of this sector. In today's rapidly evolving world, innovation has become a key driver of success across industries. The white good industry, which includes appliances such as refrigerators, washing machines, and dishwasher, is not an exception. As consumers' demands and expectations continue to evolve, it is crucial for companies in this sector to embrace innovation and adopt cutting-edge testing techniques to stay on the top of the market. So, time flies. Let's go through today's agenda. First, we have the privilege of hearing from Anna Pedale and I valuable insights into the latest test techniques thanks to her extensive knowledge and experience in that field. Next, we have a panel of technicians, team leaders, and managers from Electrolux who will represent various sectors within the company. They will share their first-hand experience on how innovation has been integrated into every aspect of Electrolux operations, from product development to quality assurance to reach customer satisfaction. Furthermore, we are delighted to have Giulio Bondani and Gianluca Bocchega from IRS presenting on the topic of new technologies in testing. Their expertise in this field will provide a deep dive into the emerging technologies that are transforming the way white goods are tested. Throughout the presentation, we will explore a wide range of topics, including the integration of artificial intelligence and machine learning in testing processes, the use of virtual simulations and digital twin to optimize performances, and the adoption of Industry 5.0 to enable smart testing and predictive maintenance. Finally, we want to encourage all of you to participate in the discussion, so at the end of the webinar, we keep some time for a question and answer session. During the presentation, you can write in the chat your question that we'll collect for this part of the webinar. Before starting, I want to express my thanks to all of you for joining us on this webinar. Your presence here signifies your dedication to staying at the forefront of industry innovation. Without further ado, I invite our first speaker, Anna Pedale, to take the virtual stage and kickstart this webinar. Thank you so much.
Good morning to everyone. So I'm Anna Pedale. I'm a senior product marketing manager in NI. And so for 5 decades in NI, we have set the standards in automated tests and automated measurement systems. And we are proud to partner with the engineers, enterprises, using our systems to solve technology challenges and build a business. Today, in these 15-20 minutes, I would like to talk to you about how a good test strategy can be really a great differentiator for your business. So let's start. There is a little doubt that the pace of technology advancement continues to accelerate. And for many of you, probably it isn't a new information, but we need to consider other dimensions as environmental impact, geopolitical policy, and the entirely new business models. Increased focus on this environmental sustainability, for example, continues to drive technical innovations and the new engineering requirements. And each of these factors creates new opportunities for business to take market share, but they also drive rapid rates of change in the engineering community. Across all industry, in fact, we serve and we see many test organizations that must balance competing business requirements. And increasing the product complexity is becoming a real big challenge. And it often to drive trade-offs between test coverage, cost, and time. And more features and more electronics are required, which means that there is also significantly more embedded code being developed and tested, which can be a challenge if you're trying to meet a very high quality standard, like quality reliability, for example. According to a recent study conducted by economists a few years ago, the number of defects found in embedded software is on the order of 10, 20 for every 1,000 lines of code. Now, this may not seem like too many, so a big number, but when you look at how many lines of code are now in everyday system, the estimated number of defects can be increasingly high. For example, a smart washing machine can have around 100,000 lines of code. As you can imagine, it's a huge amount of lines of code, and which means that you can expect somewhere in the range of 1,000 or 2,000 defects in each system alone. At the same time, we continue to see a faster pace of innovation with the new technologies, new measurement techniques, and the continued need for quality and reliability. And finally, time to market is really important, and there's always been a challenge because we continue to see market windows shorten, and many of our customers are literally sprinting to compete for new opportunities. Additional to these challenges, there is also the historical approach to test and validation inside the organization. So many of the historical approach to test and to the validation, of course, can slow product development speed and increase cost. It's common to see approach like closed and often purpose-built test systems, and many of our customers struggle to get the value out of their CapEx investment as a test requirements change. We also see massive use of manual testing and manual code, so manual generating code and data management. So they are doing measurements manually. And it is often driven by lack in the software and programming skill necessary to complete measurements and to automate them. The results of manual test procedures can often require trade-off between longer validation cycles or reduced test coverage. Finally, we often see engineering teams use disparate tools, disparate processes, and several softwares. And it happens generally in a larger organization because several sites prefer to use different tools and different systems and different software sometimes. So unfortunately, the use of different tools across the organization can reduce the cross-site collaboration and slow the development time in scenarios where multiple sites are involved. And we have seen a lot of companies that gain speed and efficiency simply by standardizing on test software and hardware across their organization. So the standardization was really helpful in their business requirements and strategy. So there is a big gap if we consider the test complexity and the resources that are available. And this gap is growing, and teams are really struggle to meet their deadlines. So it's become obvious that a change is a need, and we need to help verification and validation teams to focus more on device under test, on tests, and not on building and supporting infrastructure and frameworks. So what is NI approach? NI provides the most trust test automation technology to deliver accurate measurements and with the highest measurement throughput available in the industry. So our software is, of course, the key part of our ability to connect the customers and systems. Across the development stage and product life cycle, especially as engineering team are able to reuse AP from validation to production, for example, and also across industries because we cover and we have several customers from different industries, and we can leverage IP and test procedures across the industry we serve. And of course, the benefit of this connection is the productivity of our customer. The more efficiently accomplished tasks like hardware in the loop testing or automated device validation. And then in the last, but it's not last because it's really important, are our people. They are really the third key part of our differentiation because we have an ecosystem of NI experts, engineers, partners like RS that allow us to deliver significant value to our customers. And finally, the software-centric nature of our system. So our software connected platform that combine platform-based approach and also solutions that are adaptable for our customers. In fact, a lot of our companies or customers say that our products are open and flexible because it's true. So this approach is helpful if you need to upgrade or you need to update your system to new requirements, to new features. And this preserves also capital investment and reduce the total cost of your test. So it's for this reason that it's good to implement a test strategy because this test strategy is really the key differentiator for your business. And the benefit of test isn't just about using a better instrument or better tool. It requires really a change in the people, in the processes, and the tool that are necessary to achieve these goals. So improving product and business performance require organization to make investment in 3 big areas that are automation, standardization, and digital transformation. So automation, automate measurement is often the first step. And it provides team repeatable test data and drives the ability to scale test coverage with the product complexity when new requirements are coming. Then there is the standardization. That is the second step. And it's critical sometimes to drive organizational efficiency. And it's important so for the company and for the organization to standardize all processes and all tools. And have really a big impact, this standardization, in accelerating product development. And then you might consider also digital transformation as the final step. Some organizations often make progress in digitalization in parallel to the other initiatives. And one of the first steps is often the asset and data management. So do digital transformation concentrating with the asset and data management. And this is helpful if you want to reduce CapEx and OpEx investments. So NI approach is driving business performance. And this slide is an example on how this approach is really cross industries and allow to achieve business benefits at organization level. So we work with Hyundai to reduce time to market, for example, to 83% using a new test strategy. And that's them in reducing the development time. In Electrolux, and we will see later in their speech, we automate and standardize their laboratories. And it was really a great achievement for the company and for their products in the development process and the test process. And they achieve really the 100% of improvement in customer star rating. So it was a big achievement in their work. And then in Philips, for example, we improved the bottom line and we reduced the cost per project. So they save a lot of money with this approach. And then the last but not the least, in Corvo, we accelerate the test throughput because we adapt our technology that is flexible and open, as I said before, and they accelerate their product development. So this is really a big journey that started from the automation. Then there is the standardization and finally the digital transformation. But no matter where you are in this journey, because we have done it before, we are doing it with a lot of companies, and we have an ecosystem, as I said, of engineers and partners that can help you along this journey. So I'm happy to present this part today, and now I'm hand over to Aras. Let me stop sharing.
Thank you so much, Anna, for sharing your knowledge and expertise. So now I'm pleased to introduce a truly exciting presentation from Electrolux team. In particular, from the Porcia side, we have a group of experts who will focus on the innovation in fabric care testing techniques. They will explore how innovation has changed the development of cutting-edge washing machine and dryers, ensuring optimal performance, energy efficiency, and user experience. Furthermore, from Susegana Laboratory, we have a team that will dive into the world of food preservation. They will showcase how innovation has played a crucial role in guaranteeing freshness, safety, and storage capabilities of refrigerators based on the evolving needs of customers. Enjoy the presentation, and let's give a big virtual applause to our colleagues from Electrolux.
Welcome to the Electrolux Consumer Experience Care Laboratories. We're responsible for development of washing machine, washer dryer, tumble dryer and dishwasher. Our lab have a global footprint and we are based in 7 locations. Here we are in Porcia, Italy, then we are in Poland in Świerczyn-Żarów, in Asia Pacific region in Rayong, Thailand and Cairo, Egypt, then in North America region in Charlotte, North Carolina, and last but not least in Curitiba, Brazil for Latin America. We have more than 1,000 testing stations and the team is of more than 250 team members worldwide. Labs are composed by 3 macro areas: system and technologies for functional development of modules and products, energy declaration and cycles consumer development, validation for reliability and software system robust verification, and compliance for safety and certification. To have aligned and standardized acquisition system and data analysis, it's a key and strategical point for our developments.
The Product System Functionality Laboratory aims to develop and simplify the energy labeling and develop the consumer-relevant washing program. The laboratory counts 15 testing stations. All the stations are flexible to fit the different standard testing conditions and all equipped with the acquisition system to collect and store the processed parameter. The machine under development is connected to the testing station, and during the test, the internal and external parameters are acquired and stored and processed in real time. The operator can follow the test execution by the signal that is reported in the screen. It helps to, in real time, to check and verify if the test behaves in the right way. The collected data are processed in a standardized format to provide the final test report. The data are also processed for additional analysis or to be exported in our internal databases.
Okay, Technology and Functionality Laboratories includes different areas fully involved in the product development, like thermodynamic, fluid dynamic, MVH, chemicals and mechanics. Here an example in the mechanical lab where we are simulating the consumer behavior in the stability area, using different kind of loads. We are acquiring 24 hours per day all the data coming from the equipment such as these freelancers that allow us to measure the machine vibration and movement. The data are collected and analyzed with a dedicated cruncher to have a full picture of the potential consumer usage. The same activity and equipment are used both in Asia Pacific than in North America laboratories.
Here we are in a customer experience validation laboratory located in Porcia, part of a network of validation laboratories worldwide located. Mission of the validation labs is to guarantee the product design verification of our projects of washing machine, washer dryer, tumble dryer and dishwasher. Validated products means assess the reliability, so the working lifetime expectation, and test the product as a system, so testing the functionality of the appliance according to our internal standards and procedure developed with customer-oriented guidelines. Performance test means mainly to execute a real or simulated cycle with the different conditions of environment, water pressure, power supply, monitoring the signal from electronics inside the product and signal from external sensors. Using standard acquisition system and database developed by IRS and the National Instrument, the location of the test is not relevant for data analysis. Indeed, perform test in Thailand is the same that perform them in Italy or North America. In this way, we can increase the amount of data and get more and more information. This means that from a planning point of view, we have the possibility to manage the workload without increasing the hardware needed.
This is a consumer experience care laboratory. We are in a young Thailand. We have about 240 test stations and 50 people to support product development. For washing machine, washer dryer, top load washer, vented dryer, heat pump dryer, and dishwasher. Our location have washing and drying technology lab for performance testing, labeling testing, and functional cycle development. We have cleaning and drying technology lab for this category. We have mechanics lab for test IVE calibration with stability test. We have crane laboratory for developing product marketing properties. We have compliance laboratory for product safety test and product certification, and validation laboratory for system validation test, connectivity test, care advisor test, and reliability. Every test station we are using data acquisition system such as Lab 3000 and TP execution that we are connected and the same as global CS care laboratory.
Ciao Davide,
Ciao a tutti.
siamo nel laboratorio di Corcia. Quante postazioni avete attrezzato con materiale nostro?
Abbiamo attrezzato circa 300 postazioni di test, suddivise in due grosse tipologie, la parte di performance e la parte di affidabilità e validazione.
Quanti utenti utilizzano le rampe quotidianamente a livello mondiale?
A livello mondiale ci sono circa 1200 utenti totali che utilizzano questa tecnologia sviluppata in collaborazione con IRS, dove la maggior parte sono suddivisi, come dicevo prima, tra affidabilità e performance.
Quanto è importante la standardizzazione?
Per noi la standardizzazione è fondamentale, infatti insieme a IRS abbiamo sviluppato 3 tipologie di sistemi di acquisizione che vengono declinati per ogni postazione in base alla necessità del caso. Quindi il sistema ci sono 3 sistemi principali in cui vengono utilizzati a seconda della necessità.
Quali sono gli obiettivi per il futuro a livello di innovazione, di nuove funzionalità? Che idee avete?
In futuro vorremmo introdurre come innovazione il migliorare l'esperienza dell'uomo con la macchina, in modo tale che vengano presentati i dati in maniera più chiara a seconda delle varie necessità dei laboratori, perché le necessità possono essere diverse, però sempre rimanendo su uno standard di acquisizione comune a tutti quanti.
Per quanto riguarda l'intelligenza artificiale avete idee?
L'idea è di utilizzare sempre di più l'intelligenza artificiale per migliorare l'analisi dei dati e cercare di essere più rapidi nel trovare risposte e nel verificare il corretto funzionamento delle macchine.
Grazie Davide, buon lavoro.
Grazie a voi.
us it's quite important to have reached this high level of standardization in our data acquisition system. This allows us to have an automatic way to analyze data that we collect during our regular cycles. This means that we can provide to our test engineers data analysis on the fly, so while they are testing, they receive good insights on the cycles that they are testing by simply looking at our internal tools.
What is the innovation that you want to introduce in your test lab?
Right now, we are analyzing data, trying to gather statistics that are relevant in our opinion. This enables our test engineer to validate software faster. But this is not enough. We would like to foresee failures. We would like to get better insights on the tests that we execute and on our appliances. To do that, we would like to introduce some machine learning techniques that allow us to speed up the analysis and also to get better knowledge of the appliances that we build.
What will be the partnership with National about this topic?
Right now we are working with National in order to explore possibilities in this direction. We are trying Optimal Plus software. We are running a pilot project, taking our reliability test data and trying to figure out if we are able to foresee failures by analyzing them.
What is your dream about that topic?
My dream is that we are able to foresee failures way before they happen.
Grazie Franco, buon lavoro.
Grazie.
Perfetto.
I like to add some information about this part of presentation by Electrolux. I like to add some notes about when this process was started. It was about 10 years ago. We defined with Electrolux the mechanical standardization, the hydraulic standardization, the data acquisition standardization. This operation was made also obviously with National Instruments to define exactly what will be the right choice from Electrolux. Then we define also the software standard. We develop a custom standard for Electrolux to perform validation test, performance test, acoustic chamber test, and so on. In 10 years, we have installed the software in all the world, as you've seen before. And now, in this moment, there are more than 1,000 users that every day create data, made tests, and create a big amount of data that is now our starting point for the future, for innovation for the future. So we can switch to Fridge Labs. Gianluca.
Giuliano, ci descrivi la situazione del vostro laboratorio, quante postazioni avete, che tipo di prove fate su quelle?
Noi qua ci troviamo nel laboratorio di Electrolux Italia, divisione Special. Abbiamo un totale di 112 sale climatica e alcune sono da 2 postazioni, quindi riusciamo a testare 2 apparecchiature alla volta. Alcune, quelle recenti, invece ne hanno 4 postazioni, cioè 4 apparecchiature frigorifere oppure 2 ceste fisiche. Inizialmente il laboratorio aveva una ventina di sale, abbiamo cominciato ad installare il sistema di acquisizione dei primi prodotti della National Instruments, i fitoni, alcuni dei quali sono tuttora in funzione, quindi dopo quasi 25 anni di funzionamento sono tuttora affidabili. Dopodiché c'è stata una richiesta di espandere il laboratorio. Abbiamo cominciato ad installare delle sale più capienti per testare più apparecchiature contemporaneamente. Abbiamo iniziato anche a sviluppare nuovo software per l'acquisizione di dati delle sale climatiche. pratica nel 2013 c'è stata un'ulteriore espansione di questo laboratorio, quindi abbiamo cominciato ad avere un numero di sale di maggiori apparecchiature da testare. È nata l'esigenza di sviluppare un software, o meglio di sviluppare l'attuale software in modo da rendere più automatico le procedure di analisi dei dati. Inoltre troviamo che l'esigenza di integrare sale più datato con sale più recenti dove gli hardware erano più diversi, dovevamo integrare tutto in un unico software, in un'unica interfaccia.
Che tipo di prove fate e quanti frigoriferi simultaneamente, mediamente avete sotto testa?
Beh, da periodi, però diciamo che il 90% delle sale sono occupate temporaneamente. I test che facciamo sono quelli definiti dallo standard internazionale per apparecchiature console. E quindi abbiamo un test di consumo, test di congelamento, test di storage, test di cooling performance e abbiamo inoltre altre tre sale che sono dedicate ai test di acustica.
Avete quindi definito uno standard per tutte le nuove sale?
Sì, è stato necessario definire uno standard, quindi abbiamo 24 canali per l'acquisizione delle temperature sulla impostazione, abbiamo degli strumenti di precisione per la misura dei parametri elettrici, poi abbiamo dei sensori per quanto riguarda l'umidità e alcuni addizionali nel caso di eventuali analogici digitali.
In prospettiva, quali possono essere i vostri desiderata o innovazioni che pensate di introdurre nei prossimi mesi, nei prossimi anni?
Un'ulteriore innovazione potrebbe essere quella di integrare i dati che adesso sono acquisiti separatamente dalle schede elettroniche delle apparecchiature frigorifere per poterle comparare con quelli analizzati tramite il nostro sistema di acquisizione, quelli interni dell'apparecchiatura. E poi anche la possibilità magari di avere un'analisi in real time di quello che succede durante l'inizio del test, in modo tale che siano molte le quotazioni interessate da tenere sott'occhio dalle nostre clienti, ci sia una previsione di un'eventuale anomalia nel test, per farlo e avvertire l'utente che c'è qualcosa che non va e che sia meglio di vedere l'impostazione della partita. E potrebbe essere anche che riusciamo ad automatizzare quella che è l'attuale calibrazione, perché anche questa è una cosa che viene fatta ogni 6 mesi su ogni sala climatica, quindi è iniziato prima, che sono grossi impegno di risorse, e quindi l'idea sarebbe quella di riuscire a automatizzarla in modo tale che una volta posizionato un sistema di misura all'interno della sala possa essere una procedura che una volta iniziata si completa subito.
Perfetto, grazie Giuliano, buon lavoro.
Grazie a voi.
Grazie.
Bene, un veloce commento anche sulla a quick comment on the fridge presentation by Electrolux. Also in this case, we start to define the standard about 10 years ago, as we have said before, and we define with them all the standardization that is a climatic chamber. Consider that the climatic chamber is not a simply chamber, but there are some standard that the chamber must follow, as speed, air velocity, the stability of temperature, and so on. So we define with them the standardization about the climatic, the control system, the data acquisition system, and also the software. Also in this case, we define this aspect with national INSON, so national helps to check exactly functionalities, cost, performance. So we define the standard. And now, as Giuliano said to us, now there's a new standard to define the usage of all the data. And this is the aspect that we introduce now with the part of IRS of the presentation. Okay. In this part of the webinar, we present to you some application concerning the introduction of an innovation based on artificial intelligence and so on in home appliances testing. We like to present IRS as an innovation hunter for our clients. Our goal is to help customers improve their testing processes, introducing innovation to eliminate wasted time, improve quality, and have more information about their product. The innovation sector in which we operate are development of application based on use of the digital twin concept. Digital twin is a technology that is very useful to test correctly the unit under test with a real-time digital twin model that runs simultaneously with the testing. Obviously, application for the smart factory. So by our point of view, smart manufacturing and smart testing. As I said before, artificial intelligence are used in many applications, not only for the testing online or labs, but also in other aspects that we check later. And also, one of these techniques that we use is machine learning techniques that is very useful when we have a large amount of data to define better how our unit under tests are running, and so we can check much better the functionalities of the unit under test. Obviously, we use many analytic techniques to create dashboards, to create decision support system for our users. And this is one of the most important aspects concerning the Industry 5.0, where the user is at the center of the data. So we have a hybridation from digitalization, Industry 4.0, to the user, to help user to use correctly the data. Our experiences are on the three different platforms. So fabric car, washing machine, dryer, heat pumps, obviously for oven and hobs, and obviously for the fridge. As you know, in R&D application, we have create support for define the new functionalities of the new machine, to create new concepts, to test obviously also the concurrence in the labs of R&D. Concerning certification and validation, we create some standard, as you see before, from Electrolux, where these standards are in safety test, energy label test, validation, performance, and so on. Concerning the quality gate are in the line production, and there are many types of quality gate. We define also for that some standards that are very useful in the production line. And at the end of life testing in production line. That is a very, very important aspect for our job, because one of the most important aspects is to reduce the time to test the units on the production line, because the testing is a part of a production. So the time that we use for the testing is very heavy in the imagination of our customer. But obviously, we also have the quality, the level of quality. So quality and production, time for production are trade-off. So we must create new test system to reduce time and to improve quality. As you know, the standard architecture for measurement system are in the past based on sensor, Sensors are logged with a data logger. Data logger is connected to the PC. User use the PC to have the data, to have visualization of the graphs of the data on the tables, create reports. Sometimes, often, there is a storage with a database, a file system, and so on. But this architecture is older. It started more than 20 years ago. But the 99% of the system installed are based on this architecture. Now we want to define a new one architecture. Consider that, for example, close to the field, we have sensor and data logger. But if you use a real-time AI application, artificial intelligence application that use the data from the sensor and create some new data based on AI, machine learning, algorithms, and so on, we can create a new level of data in a real time during the process, some different sources, and create new data to test the machine. All these data are put on the network. On the network, there are network services, cloud, virtual machine, and also data lake. Data lake is a new concept. That is a new concept where there are all the data that you create. Story series, imaging, vision, data, and so on. And this data lake is a new concept concerning the starting point to create new way to analyze the data, to create report, to understand how the process is going, how the unit and the tester is going. Where is the user? The user is here. Now the user can use many different devices, and he can choose the right devices in that moment that is correct for him. So he can use PC, notebook, tablet, smartphone, smartwatch, and obviously in the future, but is also the present now, can use an AI assistant to ask what he needs in that moment. So all these devices create the user experience, the UX part of the system. And this is not directly connected to one single PC or one single database, but is a connection from all the data, so concept data lake, and based on AI that can create different prospects of the data to use in that moment for that use by different users.
This kind of architecture open up new possibilities. We are in the eve of a renaissance of intelligence by the machine. So we can put intelligence at each level of the company, of a test system, of the whole company. So we define the 3 levels. We put the field level, which is the AI intelligence at the measurement level, at the data logger level. We need real-time intelligence in order to have a control on the process and take actions immediately when there is something wrong happening. But there is not only the field, but we have a lot of context. Context is near the field. I mean, environmental sensors like temperature, humidity, air quality, but the time of the day, the time of the season, of the month, the supplier, the parts can have a strong impact on tests we are making. And with artificial intelligence put in the loop, we can take advantage of the context. So from the back end, we can imagine we have other information coming from other parts of the companies and put in the artificial intelligence algorithm. We have a middleware which is in charge to take data from the field, from the company, from the context, and have what we call a data lake. We need a place where you can find every kind of data, structured and unstructured. I mean, data warehouse, time series database like InfluxDB, and database we use usually. And take advantage of data lake using specialized hardware, because Spark in particular, where we can manage some workers to take intelligence from the data and put that intelligence at 3 levels. At the real-time intelligence, meaning on the field, as a decision support system. In order to take decision from a human level, we need to have information coming at the right time, at the right place, to the right user. And artificial intelligence is able to decide when and who needs information. And another level is about self-service knowledge, augmented knowledge. Like in ChatGPT, AI systems can bring together the knowledge at the company level, at the test system level, at the manager level, and make possible to everyone in the companies who have the rights to do that, to make questions, to elaborate reports, to create automated reports for the person who is searching for information and connection and creating value for the company. So now Giulio will show some examples of this creative value using artificial intelligence and machine learning. It's a starting point, but we think is the base. New architecture with intelligence are the base for a new kind of testing system that are intelligent, create value for the company.
Where these techniques can be installed? Everywhere. Because in R&D application, certification validation, quality gate, quality system, and production, all these techniques are very useful. Now we present to you some examples. So we start about 3 years ago with the first proof of concept pilot system, and now we present some systems that are working since a couple of years, some pilot tests that are running, and some ideas that are starting for the new project. One of the, let me say, oldest system is a fridge end-of-life test. This is an innovative end-of-life test based on AI with machine learning techniques based on the thermography data. So we catch the temperature directly from the back of the fridge, and with statistical test on this data, we can create an evaluation of the performance of the fridge. Concerning washing machine end-of-line test, we are discussing about how to improve the testing with the adaptive test based on statistics. So we can create a list of tests based on statistics, and we can automatically define what are the steps to do and other steps based on statistical analysis that cannot necessarily do every time in each single test. Also, in end-of-life tests, we have introduced some noise tests. So define the acoustic pattern based on machine techniques. So in this way, we can predict the maintenance of this machine. Professional fridge is another older application started about 3 years ago. And this is based on digital twin a real-time digital twin based on machine learning techniques and also phenomenological model. We have reduced the testing time more than 50%. And also we have reached a better quality of the test. So we can catch some defects that in the standard test system are not catch from the system. Heat pump dryer. We have used digital twin for the long time life test. And this digital twin run completely in parallel during the test, the live test. And this it's easy to check in real time the situation of each single unit on the test. And also we can define better the situation of the entire machine. This is an application that we are starting to define this moment. We have defined some pilot tests based on the AI application. In this moment, we are able to predict the value of the temperature and the energy consumption of the next cycle based on the history of the single fridge. So we can define before that the fridge reach some condition how it is working, and we can take some decision before for example, the defect happens. This is what, if you remember, Giuliano Salvadori says concerning fridge and the idea for the future to predict the functionality of the fridge. Concerning oven and hot lab, we have defined a standardization based, for example, on data lake. We use some new standards, Spark and InfluxDB, to create a unique data lake of time series data, single point data, video, and so on. This is a very important application, started about 2 years ago, and now we can add analytics in this application. This is another important idea that we are starting this day to perform that, to introduce new user experience based on AI assistant. So the dream is that the user asks directly, I need this report from this data, from that data, from that to that data, and that component. Let me create a report with all the important data, and the system can catch all this information, catch the data, create a report to improve the output of the system. Another important project for us is a human sense AI-based. Human sense, you know that it's from some measurement that we are not so skilled, not so good like a sensor. For example, temperature with a normal sensor, we can define 0.1, 0.2 degree. For us, it's impossible. But for some experience, for example, acoustic, vision, noise, and so on, we are better than the machine today. If we use correctly some AI tools, we can improve the automatic vision system and the acoustic system. We are a pilot for this. It could be a very important target for us in the next month. These are some of our applications. In our vision, mission and vision, we create tailor-made innovation for our customers. So for us, it's very important to introduce, as I said before, we have a hunter on innovation. We introduce innovation for our customer in the tailor-made system that we create for them. Okay, thank you very much.
Thank you so much, guys, for this inspiring presentation. So now we have only some minutes left for the question and answer session. However, if you have some question or doubt, we will collect the question in the chat box, or if you prefer, you can also switch on your microphone and do the question. So please. if you want.
Yeah, this is Stefano Strada from Electrolux Forlì. And can you hear me? Yes.
Yeah.
Yes.
Okay, ciao. But do you think that introducing so much high level of technology in our laboratory, do you think that a dedicated person with a deep knowledge on it should be available in order to permit to have the right managing and the right improvement of the systems that we are talking about and we like to introduce in order to simplify our work and achieve better result in a shorter time?
Stefano, I try to answer to you. First important thing that you have to add is all our applications are based on the improvement of the existing system. So we add new functionality, but the old functionality are available for the user. So if someone like to use the whole system, can use the standard wrapper and so on. Our mission is to add some feature that can help also the not expert user to catch the data and to use the data in the right way. So our idea is to create an easy to use system to find the answer to the question of the user. I don't remember exactly when I made the test. Can I compare easily the data from a test of last year, 2 years ago, last month, and so on? So it's a way to help the users to have all the information, as Gianluca said before, in the right moment, in the right way, in the right device. So if you are with a smartwatch or smartphone, you can have the information also there, not only in front of your PC. Okay.
Okay. So let's say that no particular skill in software application is needed in order to provide and to implement this new way to work in our team, laboratory team, right?
It is necessary, but some user ask to have the way to go inside the system. As you say before, Franco Corazza from Porcia Labs is an expert on analytical, statistical, mathematical models. And so, for example, he is very interested to go inside.
Okay.
So this is possible. Obviously, you need to have some knowledge and the time to do that and so on, but it isn't necessary to use the system.
Okay, very well. Thank you.
Prego.
Thank you, Stefano. Other questions?
Maybe Yuri Palermo speaking. We're curious about digital twin because it's a quite vogue term that could be used for doing a lot of things. In particular, I was curious in domestic appliance, how the digital twin can help.
We introduced the concept of real-time digital twin about 3 years ago, because we think that we can have an idea of the ideal performance of the unit under test based on 2 different approaches. The first approach is based on machine learning. So if we have many data, we can create a situation of the machine in that moment, in that environment condition, and so on. So we think that the true value, let me say true value, for the next step of the testing will be that. The other aspect is a phenomenological model that in real time calculates the performance of the variables of the machine during the test. So in these 2 environment, there are the data that run completely in parallel with the unit under test. So we can check in every time, every second, if our machine in testing are okay or not okay. And if not okay, we can also say it's not okay because, for example, there is an electrical problem, there is a problem of the motor, and so on. So it's completely, it's the digital twin of the unit under test can help us to perform better the testing and also to catch information during the test that normally are not available in the normal test. For example, the application in a professional fridge, you remember I presented it, is based on this type of digital twin. So when the machine arrives in the end-of-life testing bench, the machine is checked with a QR code, and so it's upload the models, the digital twin models, and then then start the testing. And during the testing, the digital twin check the situation. They say, okay, the machine is okay, okay, not okay. There is a problem on the, I can say, on the condenser, for example, or the fan, on electrical, so on.
Okay, thank you.
See you.
Thank you. So we are running out of time. I don't know if we want to take the last question. Okay, so I think that we are at the conclusion. So we come to the end of this insightful webinar. I would like to express my deepest gratitude to our speakers. First of all, thank you. And thank you all of you for being a part of this webinar. We look forward to meeting you again in the future events. And in the meantime, you can contact us in the mail right in the slide. So thank you and goodbye.
Bye-bye.
Thank you very much.
Bye-bye.
Bye.
Thank you.